grade 10 learners, welcome to our mathematics lesson. I am Skhulile Ncube, and this lesson is proudly brought to you by the Gauteng Department of Education. In this lesson, grade 10, we are going to look at the concept of a function, or just the function concept. Okay, right. We've done this before. It's just a change of names. We've done the input and output values. It's just something similar to that. But now we're talking about the function concept. Let's be ready for our lesson, grade 10. Make sure you have your pen, your pencil, your book. You're going to be writing notes and doing the activities. Okay, let's be ready, please, so that when we start the lesson, we don't waste time. And remember, we are engaging each other during lesson. Don't wait for the lesson to end. You have to ask your questions during the lesson. Use the line 063 629 3655. Please continue engaging us. If there's something you want us to change, maybe say slow down, say please re-explain that, send us your message and then we'll do just that. Okay, let's start our lesson. At the end of the lesson, what are you going to learn, grade 10s? We're going to learn about the function concept. We're going to understand the function concept. What is a function? And then output values. You see now, output and dependent values, just like we did in what? In grade 8 and 9. The output values are the dependent variables or dependent values. We use these things interchangeably. Okay? And then we're going to talk about the input values, which are the independent. Input, which are the independent, yes. Input, which are the independent. And then we're going to work with relationships between variables. We're going to use tables, graphs, mapping diagrams, and formulae. These are different representations of functions. Okay, there's a lot we're going to do today. Okay, and then we're going to convert flexibly between these representations from tables to graphs, from graphs to tables, from formulae to tables. That's what we're going to be doing that. Just converting interchangeably between these representations. And then we're going to understand the function notation. Function notation. And understand domain and range. Maybe it's the first time you hear about domain and range, but still the same thing. If I can say, introduce that, domain is actually the input values. Range is actually the output values. Okay, right. And then investigate the effect of A and Q on the graph of f of x is equal to ax. Don't worry about this f of x thing. We're going to discuss that when we talk about function notation. Okay, right. We are about to start our lesson. Pre-knowledge. What did you do in grade 8 and 9? We've already talked about that. We've already talked about that. Grade 8 and 9 we did input and output values. So that's what we are using. The knowledge we are using now, we're going to build up from this knowledge. Okay. Now I want us to do a baseline activity for 3 minutes. We did flow diagrams in grade 8 and 9. I want us to answer this question. Copy and complete the flow diagram. Let's do this in 3 minutes, and then after 3 minutes, we're going to mark our work. Let's try. Right, welcome back, grade 10s. Now the input value is 2. Let's put the 2 into the function. What do? We multiply. So it's going to be 2 times 2, 2 times 2, and then plus 1. What is 2 times 2 plus 1? That's 5. Please mark that. Then the next input value, it goes into the function, the rule or the machine. 2 times 0 or 0 times 2. 2 times 0 or 0 times 2 plus 1. 2 times 0 is 0, and then 1 plus, or 0 plus 1 is 1. Okay, mark that. And then negative 3 is the input value. We multiply by 2, and then we add 1, so it's 2 times 3. 2 times negative 3 plus 1. 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. Okay, mark that. Did you get everything correct? I hope so, grade 10s, I hope so. Okay, it's easy. Okay, right. We don't need a lot of time to do corrections. I think we could have managed to do the corrections as we were giving the answers. Okay, let's continue. Okay, please, if you need time, let me know. Right, what is a function? Important terms that we want to discuss. A function is a special relationship between input values, and then I'm introducing the term now, domain. The input values are the domain of the function. Yeah? That's the domain. Input values are the domain. So we're going to be getting a lot of these questions. What is the domain of this function? What is the range of this function? You must know that the domain is coming from the input values. And then output values, the range. So a function is a special relationship between input values and the output values. It is the relationship between the domain and the range. Okay, I'll give you just 1 minute to write notes after, just wait for me. And then for a function, each input value is associated with one output value. Not all relations are functions. When you see an equation and say, oh, this is a function, no, it's not like that. There are some equations that are not functions. Like, for example, an equation of a circle is not a function. I'm going to explain why a circle is not a function. Right. So a function, each input value is associated with one output value. Let me just explain that further. For example, let's say we have this formula. Remember, a function can be represented using a formula. Y is equal to 2x. X, that's where we put the input values, and then Y are the output values. And that's another thing. X is the input values, Y output values. And then if we put the input values into this formula, right? If we put -1, 2 times -1, what do we get? We only get -2. You see, one input value giving us what? One output value. 0 will give us what? 0. One input value, one output value. And then 1 will give us what? 1 will give us 2. You see that? So each input value is associated with only one output value. That's a function. Right. Now I want us to spend 1 minute writing short notes. Don't write everything. This was mainly explanation. You don't need to do it, write it. Maybe this point and this point. Just write those two for 1 minute. Right, welcome back, grade 10s. Right, one more condition for a function. It's not about one input value associated with one output value only. I just broke this into two parts so that we can understand nicely. Right, so one more condition. What does it say? For a function, two or more input values may give the same output value. Do you believe that? Let's see, using this example. Okay, what is negative? Let me use what did I use? Maybe it's fine. It may be different to what I used. I'll show you. What is negative 1 squared? If you say negative 1 times negative 1, what do you get? We get 1, isn't it? What is 1 squared? 1 times 1, what do you get? We also get 1. And remember, if the negative is outside the bracket, then you get negative 1. Now, the negative is inside the bracket. So do you see that two input values, they're giving us the same output value? Negative 1 will give us 1. 1 will give us 1. You see that? So it is possible that two or more input values may give the same output value. It's still a function. It is still a function. Like this example here, y is equal to x squared. If we square, right, negative 1, we'll get what? We'll get 1. And then if you square 1, we'll also get 1. And then 0 will give us 0. Do you see that? So now we can have this condition. It's still a function. Please write this in 1 minute. You may leave this one. I'm just explaining here, just the point there. Let's try. Welcome back, returns. I really hope that you are managing to write your notes and you are understanding. Please feel free. If we're moving fast, let us know. If you have questions, we have a team this side who are waiting for your questions. Okay, please make sure that you ask questions and you're going to be assisted. Right, and then let's go to the relation. Right, a relation is not a function. There are some relations which are not functions. Okay, in a relation, one input value gives two or more output values. One input value gives two or more output values. So in such a situation like this one, if I say, what is the square root of, say, 4? What is the square root of 4? Is it 2 only? No, it's not 2 only. It's negative 2 and positive 2. Because negative 2 times negative 2, negative 2 times negative 2 will give us what? Will give us 4. 2 times 2 will give us 4. So now, one input value will give us two output values. So this one is not a function because of that. And there's a very easy way to test if a relation is a function or not, especially if it is graphical, if it is the graph. It is called a vertical line test. Okay, let's say this is a graph that we have. I have two graphs here. I want to show you. This one, you just draw the vertical line anywhere on the graph. If it is a function, the line will cut the graph at one point. Even if we move across, you see, the line is cutting the graph at one point, anywhere on the graph. So this is a function. It's called the vertical line test. Okay, so this is a function because of that. So when you get a function, is this a function or not? Just draw a vertical line. If it cuts the graph once, it is a function. But when we come to this one, we draw our vertical line. You see, this is cutting the graph there and there. So it's cutting the graph twice. Okay, you see that? So it's not a function because of that. So vertical line test, the vertical line must cut the graph once. And then even if we move it across, you see, it is cutting the graph at two places. So this is not a function. So this is a simpler way of testing if a relation is a function or not. Remember the vertical line test. You can get a question in the exam about the vertical line test. Okay, remember that. Okay, right. Let me just give you 1 minute to catch up and do short notes if you want to. 1 minute. Right, welcome back, Christians. Let's continue with our lesson. Still on a function, we want to understand what is a function. What is a function? Right, like we said, a function is a special relationship between input values and output values, domain and the range. It's like the machine, like grade 8, 9, we talked about these machines which change things. So if you put things into the machine, what does the machine do? It changes them into something else. That's how the functions work. They change the input values into something else. Like here we have a function, we have our input values that go into the function, and then the function will change the input values into output values. I made them different because the output values are not the same as the input values. See that? But they depend. The output values will what? Will depend on the function and the input values. So that's why they are called dependent values or dependent variables. So the input values are the independent. They do not depend on the output values. So they are being independent means you do not depend on something. Okay, so the input values are the independent values, and then they are called the domain, and then the output values are the dependent values or dependent variables because they depend on the input values and the function. The other name for dependent variables is the range. Now, which ones are the x values and which ones are the y values here? I think I mentioned it somewhere. Can you answer that? Which ones are the x values? Which ones are the y values? Input values, output values. Input values, good. Input values are the x values. And then output values are the y values. Remember that. Remember that. You must remember that up to grade 12. When I say I want the range of this function, I want the y values. If I say I want the domain of this function, we want the x values. Okay? Right. And then, given the function 2x, usually it should be y is equal to 2x. Let's use it as it is. Still want to understand this thing of function. What do? We have the input values, which is 2 in this case. Every time you put the input values into the function, you must put that input value in what? In brackets. Using brackets is very, very important. So now you see where there's x, we're going to replace the x with 2. So where there's x, we put 2 inside the bracket. Very, very important. And then 2 times 2, we get the output value, which is 4. Let me emphasize the use of brackets when I use this other value. Let's say the input value is -4. And then you decide not to use a bracket. You say 2x. And then someone say 2x. Then I put -4. And then you say, this is like 2 minus 4. You see that? It's no longer the same. You've changed the operation now. It's now 2 minus 4 instead of 2 times -4. So every time you substitute, it must be in the bracket. See, now there's a total difference. It was 2 minus 4 initially, which was 2 minus -2. Then now it's 2 times -4, which is -8. So use of brackets when you're substituting is very, 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 in capital letters, important. Right, let's not forget that. And then so we're going to put our -4 where there's x, and then we get -8, you see? Right, I wanted to emphasize the use of brackets there when you're substituting. And then we have our input values and output values. After this lesson, to tell the truth, and then if you are not going to understand what an input value is, what is the output value, what is the dependent variable, what is the independent variable, what is the domain, what is range, then I don't know. Okay, you have to understand these things. Very, very important. I said the input values are the x values, then output values are the y values. Do you see that? And then they are also called the domain and range. Don't forget, input values independent, output values dependent variables. Okay, I've been talking for maybe 10 minutes now. I think you can do an activity. Let's try to do an activity. Right, try to do this in 3 minutes. Right, welcome back, grade 10s. Let's mark our work. So now when the input value is 2, we're going to have what? We're going to have 4 times 2 plus 1. So 4 times 2 is 8 plus 1 is 9. And then if the input value is 0, 4 times 0 plus 1. 4 times 0 is 0 plus 1 is 1. And then if the input value is negative 3, it's 4 times negative 3 plus 1. Then 4 times negative 3 is negative 12. Negative 12 plus 1 is negative 11. Please mark your work. Okay. And write good if you got everything correct. Right. Now, we say that the function can be represented using different ways, okay? So the relationship between variables can be expressed using tables, graphs, mapping diagrams, and formulae. So we want to do that part now. So we're going to use the same example or same function to have these different representations, okay? Right, let's do that. So we have the function f of x is equal to, or y is equal to x squared. This is the flow diagram. You see the input values will give us the output values. So if you're asked to do the mapping diagram, what do you do? This is how you do it. So you have your input values on one side and then the output values on one side. Please take note, we're using this. So these are the input values, these are the output values. Okay. So negative 2 will give us what? 4. Oh, okay. Negative 2 will give us 4. 2 will also give us 4. 0 will give us 0. 1 will give us 1. And negative 1 will give us 1. You see that? So that's the mapping diagram. So this is how you represent the input and output values using the mapping diagram. Okay. Let me give you 1 minute to do your notes. And then after the 1 minute, I'm going to give you a short activity. Just try to do it 1 minute. Right, welcome back, grade 10s. Please, if I give you a minute to write your notes, please don't copy everything that is on the screen. You cannot finish. Just pick the things that you think can assist you. And you don't need to write everything in full, just short notes that will assist you later, okay? Let's do that so that we don't waste a lot of time. Now, let's do the activity. I want you to represent, consider the following ordered pairs. Oh, we didn't talk about ordered pairs. Right. Ordered pairs, let me just show you, means x and y coordinates. We've done x and y coordinates, isn't it? Right. So the first one, the first number, that's your input value. And then y, your second number, is your output value. You see that? So these are the ordered pairs. So it means in a function, let me give you the first one. In a function, negative 2 is the input value, and then the output value is negative 1. So negative 2 will give you negative 1. So I want you to use these ordered pairs. How many of them? 1, 2, 3, 4, 5. To draw a mapping diagram like I showed you in the previous example. Let's try to do this in 3 minutes. Right, welcome back, returns. Let's mark our work. The mapping diagram, we have the input values, -2, -1, 0, 1, 2. See, these are the values there. And then we have our output values, -1, 0, 1, 2, 3. See, these are the output values. -2 will give us -1. -1 will give us 0. 0 will give us 1. 1 will give us 2. And then 2 will give us 3. Let's mark our work. Did you get it right? Okay. Right. So this is how you convert from ordered pairs to mapping diagrams. Remember, we said you want to convert interchangeably between these representations. Right. The given function can be expressed using a table. You know the table of values. Okay. This is how the table of values will look like. We have our input values, which are the x values, and then we have our output values, which are the y values. Okay. You see, -2 will give us 4. And then -1 will give us 1. 0 will give us 0. You see that? 1 will give us 1. You see that? Then 2 will give us 4. You see that? Okay. This is how you represent what a function using a table of values. You see? Now from the float diagram to the table of values, or even from ordered pairs to table of values. You should be able to do those things. Let me give you 1 minute to just make your notes. Right, welcome back, returns. Let's continue. Right, I'm going to give you a short activity, maybe for 2 minutes. Right, let's say 3 minutes. It's fine. Consider the following ordered pairs. Now, I want you to represent these ordered pairs using what? A table of values. Let me just give you the table of values, then you can copy it. Where is it? Oh, here. Just for 3 minutes. From ordered pairs to table of values. We discussed the ordered pair in the previous activity, isn't it? Now you know the first number in the pair is your input value. The second one is your output value. Input value are the x values. Output value are the y values. Okay, let's try to do this in 3 minutes. Right, welcome back, greetings. I really hope you managed to come up with your table of values. -2 will give us -1. -1 will give us 0. 0 will give us 1. 1 will give us 2. Then 2 will give us 3. Okay, see. So these ordered pairs, they represent what? Function. Input, output. The table values represent also a function. We have input values, output values. See that? Okay. Right. And then the function can be expressed as a set of ordered pairs. I think we have discussed this, so let's just go through it. So we said -2 will give us 4. You see that? -2 will give us 4. And then 2 will give us 4. You see that? It's an ordered pair, input followed by output. So now it's from the flow diagram to the ordered pairs. And then 0, 0. And then 1, 1. And then -1 will give us 1. Okay, so we have done this. Let's not worry about this. Just know that we can have our change from one representation to the other. Okay, so remember we said it's tables, graphs, mapping diagrams, and also graphs. What I said, tables, graphs, mapping diagrams, and formula. Okay, so those ones, you must know those ones. And then the function also can be expressed as a graph. You don't need to write this. Let me just show you. Okay, you don't need to write anything. Otherwise, say draw the graph. It will take time. So now we can represent a function or input and output values using a graph. Like we said before, when we say that we can use the vertical line test to test if the graph is what, or if a relation is a function or not. Okay, so how do we do that? Using our ordered pairs. Like the first one, -2 will give us 4. -2 is your x value. So this is our x value. Oh, let me have put my y values. Yes. And then the y value is 4. So it means this point. That's -2 and 4. You plot the point like that. That's -2 and 4. And then we go to -1. -1 will give us 1. So we have that ordered pair, and then we can plot it like this. Please don't draw the graph, otherwise it will take time. Then we come to 0. 0 will give us 0. Let me just show you 0, 0 there. That's the origin. And then 1 will give us 1. See, 1, 1 there. And then 2 will give us 4. Okay, input value of 2 will give us output value of 4. You see that? And then these points can be joined, and then we have our graph. So do you see that we can have a function represented using graphs? Okay, right. And then also we said the function can be expressed using a formula. I think we have done that. So like y is equal to x squared. This is your output value. This is your input value. Okay, so that's how we have the different representations of a function. I think we've covered that part. Let's move on to the next part now. We have about 15 minutes. I think we can do a lot in those 15 minutes. Right. I want us to talk about functional notation. Still under functions. Functions can be represented by using functional notation. Now, you will see that you check box instead of saying y is equal to 2x minus 3. And then you find it's written like this. F of x is equal to 2x minus 3, or g of x is equal to 2x minus 3, or h of x is equal to 2x minus 3. What is the meaning of that? It's very, very important that we understand that part. Okay, just listen. I'll give you time to write down. Right, so this is the read as. This is how we read this. We say f of x. This is f of x. That's how we read it. When it's g of like this, you say g of x. When it's like this, you say h of x. M of x. You see that? So it is read as f of x is equal to 2x minus 3. That's how you read it. Don't say fx is equal to 2x minus 3. No. F of x is equal to 2x minus 3. The x here is your input. You're putting x into the function. Okay, that's your input value. Right? And then in this notation, f of x is the same as the y value. You see, it's like we have replaced the y with f of x. So f of x just means the y value. That's what it means. Okay? And then, oh, okay, before I move on, let me give you time to write notes. Okay, right, write your notes just for 1 minute, then we move on to the next slide. 1 minute. Right, welcome back, returns. I hope you managed to write your notes. Now let's move on. Still on this explanation, what f of x is equal to 2x minus 3 is. Right, f of x is equal to 2x minus 3. Determine the value of f of negative 1. What is the meaning of this? F of negative 1. Do you see that negative 1 is replaced x? So it means negative 1 is the input value. Where there's x, we put negative 1 to get the output value. So where there's x, we put negative 1. So f of negative 1 means the value of y if x is negative 1. That's what it means. If x is negative 1, what is the value of y? Okay? Right. And then so what do we do? Where there's x, put negative 1. So where there's x, we put negative 1. And then we say f of negative 1 is equal to 2 times negative 1. See, we have replaced the x with negative 1. 2 times negative 1 minus 3, which is negative 5. Okay? 1 minute. And then after that, I'm going to give you a short activity. 1 minute for you to write notes. And then we do a short activity after that. Let's try. Right, welcome back. Let's try this one. Given f of x is equal to 2x minus 3, determine the value of f of negative 3. Can you try to do this in 2 minutes? Then after that, we're going to do this together. Let's try. Right, welcome back, grade 10. Let's see what you're supposed to do. So f of x is equal to 2x minus 3. Then what about f of negative 3? So where is f of x? So where is x, where is x, we put negative 3. So it's going to be 2 times negative 3 minus 3. Then f of negative 3 is equal to negative 6 minus 3. F of negative 3 is equal to negative 9. You see that? So if the input value is negative 3, the output value is negative 9. We can even write it in ordered pairs and say negative 3 will give us negative 9. See that? Okay, right. Now, we've done this part of the function notation. I want us to go to the last part. The last part is a bit different. There are a lot of things in the lesson, remember? And then the last objective, remember what I said? We're going to look at the effect of A and Q on the graph of f of x is equal to ax. Now we understand what f of x is. It's just like saying y is equal to ax. So this part, if we check, we're left with 4 minutes. So we cannot do it step by step nicely. I want to explain. You'll treat this as a highlight of your next lessons. Okay? So I just want you to just sit and listen to me as I explain. You learn 1 or 2 things. Okay, right. Let me just take you through this concept. Consider the functions y is equal to x. We call this one the parent graph. The blue graph, we call it the parent graph. Then y is equal to 2x and y is equal to x plus 2. So we have this formation y is equal to ax plus q. So we want to see the effect of the a and the effect of the q. So in this case, do you see that the q is like this 2, and then the a is like this 2? Here there was 1, it's 1, there is 1, so not there was, there is 1. So if the a changes from 1 to 2, what happens to the function? And then if there's a plus 2 there, what happens to the function? Just like highlights in 3 minutes. Right. Now, we are going to substitute our input values into the function. So where there's x, we put negative 2. Anyway, y is equal to x means y and x must be the same. So we have negative 2 there for x. We have negative 1 there. We have 0 there. We have 1 there. We have 2 there. That is for this parent graph. Okay, let's go to the second one. Y is equal to 2x. Please, I said, just sit and listen. Don't write anything. Just sit and listen. Okay, it's a highlight for your next lessons. So y is equal to 2x. Where there's x, we put the input values negative 2. Like if you say 2 times negative 2 will get negative 4. 2 times negative 1 will get negative 2. 2 times 0 we get 0. 2 times 1 we get 2. 2 times 2 we get 4. See that? So these are the output values. And then the last one. Where there's x, we put negative 2. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. So this is our table of values for all the 3 graphs. We want to observe something. That's why I said we are investigating. Okay, we want to investigate to see the effect of A and Q. Let's sketch these 3 graphs. Okay, don't sketch, just listen. Okay, just listen. So the graph of the parent graph is going to look, if we use the table of values, it's going to look like this after sketching it. And then the graph of y is equal to 2x is going to look like this. Okay, I use those points. You can check later. And then the graph of y is equal to x plus 2 is going to look like this. Okay, right. And then let's discuss these 3 graphs. What do you notice about the value of a in each graph? Right, if you check, a here is 1. A here is 2. Then a here is also 1. A is equal to 1. Right. Let me check the parent graph. Do you see that change in y is equal to change in x. Remember last lesson we talked about gradient. You see that the gradient is 1. Vertical change over horizontal change. The gradient is 1. So A represents the gradient of the graph. Okay? Even this one, you can take this one. You can take these two boxes. Change in y is equal to change in x. So change in y over change in x is going to be 1. So A represents what? The gradient. Please don't forget that. Okay? And then compare the slope of y is equal to x and y is equal to 2x. Which one is steeper? Y is equal to 2x is steeper than y is equal to x. The higher the gradient, the steeper the graph. The higher the gradient, the steeper the graph. Okay? Right? And then compare the slope of y is equal to x and y is equal to x plus 2. Do you see that they are parallel lines? And then what did you say about parallel lines in the previous lesson? They have the same gradient. The gradient is 1 here, the gradient is 1 there. See that? They are parallel, they have the same gradient. How do the graphs of y is equal to x and y is equal to x plus 2 relate? The blue graph and the black graph. So it's like the blue graph was shifted by 2 units upwards to form the black graph. You see, 2 units upwards. So the plus 2 means the graph is shifted upwards by 2 units. What about negative 2? What is going to happen? It is going to go down by 2 units, okay? Treat this as like highlights of the next lesson, and now you have an idea of what you're going to learn in your next lessons. Not necessarily the live lessons, but the other lessons, okay? Right. And then just for 1 minute, copy your homework, and then after that we summarize our lesson for 1 minute. Right, welcome back, grade 10s. Okay, let's summarize our lesson. A function is a special relationship between input values and output values. And then input values are manipulated or changed by a function to obtain the output values. Input values are also called the independent values, are also called the domain. They are also the x values. Then output values are the dependent values, called the range, also referred to as the y values. Okay? Right. Thank you very much, grade 10s. We are going to meet in our next lesson. Don't miss the lesson next week. Goodbye.